Glidewell Laboratories is a massive manufacturer of crowns, bridges, implants, and other dental lab products. They've developed an assembly line workflow based around Ember 3D printers for creating crowns and copings. Here is their process for making porcelain-fused metal dental crowns. They start by 3D scanning a dental impression, which yields a 3D mesh of the patient's mouth. A dental technician inserts a model crown into the mesh of the mouth. They use specialized software to orient and size the crown. The red regions indicate occlusions. This is where the model would collide with other teeth. The technician pushes and pulls on the mesh to make sure the tooth will fit. This digital mesh is sent to a second technician who performs quality control. This is similar to the previous step, but this technician is more experienced and makes sure that the shape of the tooth looks natural. Next, the models for the crowns and copings are prepared for 3D printing on Ember. A tech uses special dental software to add supports onto the model. Then the models are tightly arranged in a plane. This nesting allows many crowns to be printed at once, improving the efficiency of the process. Now this collection of crowns is sent to an Ember printer. A tech starts the printer. The print time is typically around 40 minutes. Glidewell uses a specially formulated resin, which will completely burn out later in the process. After the print is done, a tech removes the build head from the printer, scrapes off the print, washes it in alcohol, and dries it with an air gun. Then the print goes through a post-curing step under a UV lamp. Because the print can have multiple crowns from multiple patients, they create a sheet for each print. The sheet has an image that matches each crown and coping on the print with a specific patient. For example, the image labels crowns number 1, 2, and 3, which match these crowns on the print and these cases for a patient. The 3D printed crowns are removed from their supports and are packaged into adorable tooth-shaped containers. A technician takes a 3D printed crown and skillfully applies a thin wax coating on the print. This coating smooths the microscopic roughness from the printing process and will yield a very shiny finish on the final part. Another technician sprues the crown. They use wax to attach it to a stem. This will create a passage for metal to flow into the crown during the casting process. The sprued crowns are put into a mold and a technician mixes up the investment material and pours it around the crowns. When the investment is completely set, it's put into an oven until the heat completely vaporizes the wax and 3D printed crown, leaving a crown-shaped void inside the investment. Directly from the oven, the investment is inserted into a vacuum casting machine. Already inside is a precious metal alloy. The machine flips over and a vacuum pulls the molten metal into the void space. The casting is removed from the machine and left to cool. In a process called divesting, a technician breaks apart the investment with a hammer and uses an air gun to remove any remaining pieces of investment. He cuts off the sprues and weighs the castings to determine the price. These castings then go through a polishing step. This metal casting will form the substructure of the final crown. Next, an opaque layer is applied to the casting. It acts like a primer. It covers up the gray color of the metal and also increases adhesion with the porcelain layer. To create the porcelain layer, an anatomical top is first 3D printed on Ember in castable resin. The top slides onto the opaque casting. The casting and top are then attached to a wax sprue. The part is surrounded again with liquid investment. After it solidifies, it's put into an oven where the wax and 3D printed top are melted out, leaving the metal coping embedded inside the investment. A special ceramic is shot into the mold, filling the empty space. After cooling, the investment is removed. The metal substructure is now fused to the porcelain coating. They remove the sprue, and the crown goes through some finishing steps, including detailed painting and glazing, which gives the crown a natural, tooth-like appearance. It is now ready to be shipped back to the dentist, who will place it in the patient. Thank you so much to Glidewell Laboratories, who produce roughly 1,000 crowns, copings, and anatomical top units 3D printed on Ember per day. It was so much fun working with you all, and it was incredibly instructive to visit your labs. We really appreciate your hospitality. So, if you'd like to learn more about using 3D printing for production, please subscribe to the channel. And to learn more about Glidewell, check out their YouTube channel. They have lots of great videos. Thank you so much for watching, and have a great day.